For years, the tech industry operated on a simple premise. To make artificial intelligence smarter, you just build a bigger data center and feed it more electricity. In June 2026, the United Nations issued a report stating that this strategy has hit a physical wall. The expansion of AI infrastructure is now directly colliding with the planet's ecological limits. By 2030, AI systems will consume 945 terawatt-hours, equaling the annual power of Pakistan, Bangladesh, and Nigeria combined. This massive electricity requires cooling. A kilowatt-hour of AI computing uses 5 liters of fresh water in the US, but constraints in Brazil drive that to 29 liters. Earth's physical resources have become the hard limit for the brute force scaling era. To bypass terrestrial power grids and climate regulations, the tech industry is lifting its physical infrastructure into orbit. A $920 million contract between Google and SpaceX marks the beginning of the orbital data center era. By moving servers into space, companies can utilize the extreme cold for cooling and constant solar exposure for power entirely off the global grid. Back on the surface, the focus has shifted to moving the computational workload off the cloud and directly onto consumer hardware. NVIDIA's RTX Spark architecture compresses 1 petaflop of AI computing power into the chassis of a standard Windows 11 laptop, processing volume that previously required a dedicated server rack. Space-based servers and high-end laptops are temporary mitigations. Long-term survival requires a change in the architecture of the models themselves. To function within these hardware limits, developers are stripping away the computational overhead of modern models. Google's Gemma 4 uses quantization-aware training to account for data compression during the learning phase. This allows a massive model to retain its capabilities while fitting into a memory footprint of just 1 gigabyte. This diagram illustrates Tencent's Sten sparse attention algorithm. By identifying and processing only the most vital tokens in a document, the system reduces the required compute power by 75%. By stripping away this compute overhead, models can now remain continuously active in a device's memory. This shift from a reactive tool to an always-on process creates the runtime environment necessary for autonomous agent loops to function. This persistent execution is visible in OpenAI's Dreaming v3 architecture. Instead of waiting for a user prompt, the model idles in the background, automatically synthesizing and refining long-term memories. Internal data from Anthropic shows the result of this constant operation. The Claude model has entered a state of recursive self-improvement, where the AI engineers its own updates. Claude now writes 80% of its own internal engineering code, rewriting its underlying architecture at speeds that exceed the monitoring capacity of human teams. Developers have stopped writing traditional syntax. Their daily workflow has shifted to managing high-level loops that coordinate these autonomous agents. The engineering workflow is now a matter of supervising these self-evolving agent loops. This autonomous code generation creates a security gap. AI can identify and weaponize vulnerabilities faster than human teams can audit and patch the results. This imbalance has led to the miasma worm, a new breed of supply chain attack that targets AI programming assistants directly. The worm hides within a code repository and waits for an autonomous AI agent to read the infected text. The moment the AI parses the context window, the malware executes, compromising the developer's environment. The digital ecosystem has become too complex and automated for traditional human cybersecurity to protect. Governments now recognize that autonomous, self-coding AI infrastructure is a critical national security vulnerability. In response, the United States and Japan formed the Genesis mission, a $1 billion defense pact designed to hoard compute resources and corner scientific discoveries generated by AI. This alliance marks the end of the open global internet and the beginning of a reactionary balkanization of AI technology. Europe and Canada launched a counteroffensive against U.S. tech dominance through a $20 billion merger between Cohere and Aleph Alpha. This platform uses a GDPR-native architecture. Through hard-coded infrastructure protocols, it ensures that government and corporate data physically stays within Europe and Canada, preventing any transmission to U.S. servers. The French military has already moved this doctrine to the field, deploying Arcadia, an AI command system built entirely on indigenous software, independent of American platforms. The era of AI as a borderless consumer tool is over. As these systems run in orbit and autonomously write their own future, Humanity's role is to police the borders of these sovereign AI networks and guard the values we feed them.